Greetings to all my esteemed participants. I hope you all are doing great and in good health. My name is Mubashir Mushtaq, and I'm the regional manager for MEA and India, SatLab Geosolutions. I warmly welcome you all in this webinar today, which is detailed overview and the narration for roads in Satsurv. I hope you can hear me very well, loud and clear. And let's get started. Well, in this webinar, we have 3 segments, which is okay. The first content that we have is brief introduction of roads in Satsurv, designing of roads in Satsurv, and how to carry out road stakeouts in Satsurv. So let's get started with the first one, introduction of roads in Satsurv. So there are some examples of different types of roads in the real world, and let's learn how to design these roads in Satsurv. So you can see all these roads here with the here. One second. So as you can see, this is my okay. All right. So this is my hairpin band curve in the hill roads. As you can see, there are different other roads. So let's see how this whole designing of the road started. So it starts with first, that is your survey. That is, we understand the chronology of road design and highway engineering. So first one is what we do when we are going to design any roads. First of all, we're going to go for the map study. In the beginning, various data in the form of maps, aerial photographs, charts, and graphs, etc. are collected. And these graphs and maps you can collect from the concerned department just to give a what we can say is a recce survey, or we can just fixing an alignment. That's it. We're not doing anything right now. We're just fixing a alignment. And after, when we fixed an alignment, we go for the preliminary survey or the recce survey, where we just identify the terrains, the physical features, both man-made and the environmental. After all of these things, after this part and this part we are done, we go with the detailed survey. So in the detailed survey, so right now this is an entirely a brief thing, because I'm not going into the details right now because it's a very vast field. So in the detailed survey, there are a couple of steps. First step is that is my strip plan. So my client is asking me to make the strip plan, that is a detailed strip plan of the site plan with the fixed corridor. It's collected with the help of GNSS and total station. Before, I guess 4 or 5 years back, the total station are more prominent, and these kind of surveys are done with the total station only. But now the GNSS technology have increased immensely, and you can do the precise survey with the help of the GNSS equipments. So what exactly the corridor is? The corridor is, say for example, this is my alignment, this is the left side, this is the right side, and this is the whole corridor, which is, say for example, 200 meters. So this will be my corridor. So my corridor is 100 meter left, 100 meter right. Okay. So the next step is collection of cross sections and L sections. While doing the site plan and the strip plan, what I'm doing is I'm collecting the cross sections. That is, I'm collecting the NSLs or the OGLs, the natural surface level or the original ground level. That is, this is, say for example, my road. I'm collecting my cross sections with the cross section interval of 10, 20. And simultaneously, we are collecting the data for my L section, that is my longitudinal section. The cross section is what it's the section which is along the width of the road, and L section, longitudinal section, which is the section along the length of the road. So this will be my L section here. So L section helps us to fix the gradients and to design with the profile. So once we are done with it, we go for the processing of data. The collected data are then being processed with the software like AutoCAD, 3D Civil, AutoCAD Simple, AutoCAD, or there are many other softwares in the market right now that you can process your data with. And once the data is processed, now the designing part comes up. So in the designing part, what exactly are these? So these are the geometric design. First one is your horizontal alignment details. Second one is your vertical alignment details. Third one is the cross-section alignment details, super elevation, cut and fill quantity, and this particular cut and fill quantity you can have it if you're designing the hill road specifically. And then comes the side slope. So we're going to talk all of these things here in this webinar one by one. Okay, so let's find out how to design the roads using the Satsurv. So what Satsurv is our software which we are using in all our GNSS procedures. It's our field software. So let's find out how to design it. Design roads using the Satsurv. There are some terminologies that we are using in your software. Center line, many of you guys have already known all of these things, as a intersection method, cut and fill. So these are all the things that we're going to discuss, and we're going to discuss it one by one. It's kind of a bit messy, but yeah, we'll sort it out. Okay, so let's start with the design of roads. So first is, this is your prompt. The prompt is when you click on our road design icon in our software, this is the prompt that you'll see. In this, you will see the road name, then you will see the break chain, center line, profile, cross section, side section, construction design. So the center line is termed as the alignment, profile is termed as the vertical profile, cross section, and so on and so on. So alignment, let's see what alignment is. So alignment is this, the center of this particular road. As we have see in the graphical representation, this yellow line is my horizontal alignment, and the same thing we have shown in our Satsurv software. So this is my center line, these are my offsets over here. I'm being clear so far. So let's go ahead with the first part, which is alignment of roads using Satsurv. And we have three methods. You can design your horizontal alignment in the Satsurv with three different methods, which are the intersection method, the element method, and the coordinate method. I mean, you can use all of these three methods to design your horizontal alignment while using the Satsurv software. So let's start with one by one. First one is intersection method. These are the intersection method in which we have TP, the line, tangent point. The more important here is these two, the IP1 and IP2, that are the intersection points, and then there are the tangent points, TP1, TP2, TP3, TP4. So this is just a default thing over here. You can have a different sort of a road with the different things over here. This is just a graphical representation, or you can see it's a default road where we have managed to make you understand the beginning point and the tangent point over here, the IPs. And okay, let's see how to input the parameters. So inputting the parameter is first the name of the intersection point. It's obvious. You have to give the name of the intersection point. Then the coordinate of intersection point. It's compulsory that you have to give. You should know the coordinates of the intersection point. And after then, there comes the station. That's more important. The station, you have to know the station where exactly your intersection point is. All right. And after then, you had to give the radius, the arc, the spiral, the length of the spiral in, the length of the spiral out, and the virtual point. If you have any virtual points, you can do it. It's not necessary to have virtual points. So let's start. Let's see how to input parameters in Satsurv by intersection method. So first one is the beginning point. The beginning point is more important, that you have to give the coordinates of the beginning point over here as well as the station. After giving the station or the coordinate point, because I don't have any kind of radiuses or spiral in, spiral out, so I'll put it at 0, 0, 0. Then I'm giving the coordinates of intersection point, that is IP1, the northing, easting, and station over here. Then after, then obviously I have to give the radius of this part, and I have to give the spiral in, spiral out. So this is my spiral in, this will be my spiral out over here, and then comes the radius. Hope you understand. I have to do all of these parameters in this particular part. And as you can see over here, this is our previous version, sorry. And this is our new version of Satsurv, where you can use just simply the spiral parameters. If you're designing the roads in your software, you might know there is a big difference between this part, and we have now the parameters. Okay. And we have a small video where we are showing you how to input all these details in intersection method by using intersection point method. Road design, simple, easy, add. If you okay, in this part we have the file as well, so we can load the file. More, load the file. Click. There it is, PHI file. We have already managed to input some of the data here. So this is the beginning point where radius is 0, spiral in is 0, 0, 0. Then comes the intersection point, the various intersection point. These are all the intersection points. I'm not giving any other thing, just the intersection points. That's it. This is GD 38, 39, and all of these parameters you have to see by yourself, or you can check with your designer or your engineer, and they can give you all of these details. Radius, the spiral in, the length of spiral in, the length of spiral out. It all depends on what exactly you are designing. That's it. So once I'm done, I can view. This is the view of my road. All the intersection points are there. Just okay. Go back. Save it. That's it. I'm done with my road alignment. So there are many other things that are now crossed. So you have to design all of these things. First, my road alignment is done with the help of intersection method. Now we're going to check, we're going to see how to do the same thing while using the element method. I personally use the element method. Some other surveyors are much comfortable while using the intersection method, but I most probably go for the element method. So in the element method, let's just keep it clear. In the element method, we have to give the beginning point, the length of the line, and after then there is the spiral length. There I have to give all of these parameters one by one. So these are the description of input parameters. First, we have to give the start point. That is obviously the start point is we have to give in intersection as well as in elements. So in start, we have to give the coordinates of the start point here, and azimuth if you have an azimuth, if you have any angle. Then after that I have the line option. Okay, then after the software will ask you, okay, you have given the point over here. Tell me, do you want a line? Do you want an arc? Do you want a spiral curve? What you want? So so we'll show you how we can design all of these things. There is the arc parameters left and right, and there is the spiral parameters also here. So we have all of these things. Let's see. Input the parameters of road element in order from starting point. That is the BP, that is the beginning point. I'm giving the beginning point as 0, 0, 0. And after that, I'm giving the length of the line, that is 100 meter. Offset will be 0. And if I'm giving the offset over here, there will be another line like this. You understand? All right. So after then, there is a spiral here. Then there is an arc over here, or my parameters that I can set. So this is the left direction or the right direction. See for example, my line is like this, and I'm giving the direction of my spiral as right, so it will be like this. Or I can give it as a left, so it will be like this. Simple and easy. There's no rocket science so far. Done. Again, we have a small video for you to make you understand better how we can design the horizontal alignment with the element method. Exactly the same thing. Go to the road design, give the name of the road. And after then, you can choose line, arc, or whatever you want. Starting radius will be infinity, and radius you have here. Nice and easy. We can add another spiral curve. Start radius 100 and the end radius will be infinity. That's it. Length, say for example 50 meters. Add another line. So you can add the different segments, and you need to give the, if you are going for the line, you have to give just a simple the length of the line and the azimuth and so on and so on. This is how you can see over here. So it's the same thing that I did in the previous one. I'm just saving the alignment. It's done. And after then becomes the coordinate method. The coordinate method is similar to the element method, but here we are just using the coordinates. That's it. We are using the northing and easting. That's it. We're not using the spiral in, the spiral out. It's specifically this particular method. It's being rarely used because there are no smooth curves and all. I'll show you over here. So in the description parameters we had to give the station first, that is northing easting. We had, say for example, at 0, 0, 0, and after then we had to give the line. We have only line and arc over here. If you have line, you can give the station coordinates of start point and the end point. And this is something important that you need to know. After you define the end point of the current element, it will automatically be the coordinate of the starting point of the next element. I can show you how. So here we had here the end coordinate, radius obviously, and the direction. That's it. So this is first, this is my beginning point. Say for example, my beginning point is 0, 0, 0. Then my A point will be 5 by 5. That means this one is 5 by 5. Northern easting is 5 by 5. And after then, this particular part is B, that is 10 by 10 with the radius. So this A is over here. If you understand. So this is the end coordinate of this part will be the first coordinate of my next element. And we have a video of the coordinate method as well. Exactly the same thing. Central line, here it is. Go to the coordinate 0, 0, 0. Add, you can add a line 5 by or 2, 2. That is the coordinate. I can use whatever I want. That will be the radius, of course. If I'm going for arc, radius is 3, left to right. Then I can add another part, that is, I can add an arc or a line, depends. So it will automatically be phased as 5 by 5. That's it. Done. Line again. Can give 1, and it depends. Can view, you can see. As you can see, there are no smooth curves, and this is the only issue here. That's it. The rest everything is fine. So these are the coordinates that you can check in the display menu in the information bar. Simple, easy, save it, apply, okay, and it automatically save as your horizontal profile. So after the horizontal profile, we have a quick pole break. It's a minute pole break. So which method of designing the horizontal alignment is more convenient? What you feel is more convenient? Is it convenient to go for a coordinate method? Is it more convenient to go for the element method, or is it more convenient to go for the intersection method? I have repeat again. So this poll is, which method of designing the horizontal alignment is more convenient, or you feel it's more easy? Is it coordinate method? Is it element method? Or is it intersection method? I mean, these polls are for internal part. Maybe we can help to improve our design or software. So it's one that's quick. Good breaks are must. We all are humans. Yeah. All right. 20 seconds left. 5 seconds left. Quick. Okay. Thanks for your work over here. After, okay, let's start. So we have done our horizontal alignment so far. Now the vertical profile. So vertical curve, it's vertical curve provide a gradual change between tangents of different grades. So what exactly are those? So this is my sag over here. As you can see, this is my sag. This is my point of vertical curve, point of vertical intersection, vertical tangent. So let's design. Let's see how we can design all of these things. So in this particular part, sometimes we may have the sag. We can call it a sag, or sometimes we have the crust. So let's see how we can design the sag and the crust. This is the profile view in our software, in which you can understand this is 0 from 0 to 1, from 1 to 2. This is total, it's 200. Okay. It's 200, and this particular T and E. Okay, I'll just make you understand what exactly this T and E is. Say, for example, this is my curve over here. This is my point of intersection, right? PVI. And this is point A to point B over here. This part is my T. And this particular elevation, the distance, the E is the distance of PVI to the bottom of the sag. So this is my E. And T is, this is point A, point B. The horizontal distance between AE, this part, AE, and BE. Okay, right. So how to input the vertical intersection PVI in Satsurv? So this is more important. The Satsurv can only support circular curves from into straight lines. These are small video of the vertical profile. So in this vertical profile, you can see that we can, we have to give a proper station where we are going for the sag, or we are going for the crust. So say, for example, the station is, right now we are taking it as 0. We can give it the proper station, the proper point. And the height is, say, for example, 54.7331. And the radius will be obviously 0 because it's the first point. It's how the sag started. And after then the second point, say for example, it's at, we have started it again just to show you. The height will be, the radius will be 0. Okay, at the second point is at 100 station. And after then I have to give the height because it's sag, so the height will be less than the point E, that's 53.3 only, 54.3 only, sorry. And after then it comes back to normal, 254.7331. So there you go. As you can see over here, this is the whole graphical representation of what we have designed so far. Station 40, as you can see, there are you can change the stations as you want. Say for example, we have a station from 0 to 100, from 100 to 200. You can check the details of station 40, station 50, station 60, whatever you want. Okay, this is the vertical profile. Now comes the cross section, which is quite interesting, and I think that I'm fascinated with the cross sections. Okay, so cross sections shows the position and the number of vehicles and the bicycle lanes and sidewalks along with the cross slopes. So this is the top view of the cross section. This is my road center line over here, and these are my cross sections. As you can see, the small dots, these are the different points that we have collected the data on, and after then you can see there's a road distance as well of 10 meters. That means it has a cross-section interval. Say for example, it's 10 meters, 20 meters, 30 meters. It depends. So I'm just gonna delete it. Right now, there you go. So this is the typical cross-section of the road, in which I have a crown over here. This is my center point here, and after then there's this roadway, or in some countries we can call it as carriageway. And after the carriageway you can see the small curbs over here. The curbs are done. After then there's a sidewalk, a green area, then there are these side slopes over here. And I can show you a detailed cross section, normal cross section, or you can say ideal cross section. Normally it's like sometimes like this. This is my slope, this is my CP over here, center point. This is my left bitumen top, LBT, or we can call it RBT, the left right bitumen top. And after then there comes the shoulder. There's a shoulder there, and after the shoulder then comes the drainage part here. This is my drain. This is my carriageway. This is my crown over here. So this is my ideal cross section. And after then there comes the cuts and the fill slope. It depends how you're designing the cross section. Okay, let's drop it. That's it. So, and this is the graphical representation of roads that you can see in Satsurv. You can see the gradient, you can see the curves, you can see the sections over here. And let's quickly see how to design this cross section, because it's way too much easy. So first of all, we had to give the name of the road here. Done. And after then we had to get the gradient, or we had to get the ratio. If it's in some countries they are using ratio, in some countries gradients, it depends. And after then we had to give the width, we had to give the curve width, we have to give the construction height if optional. The construction height is, this is the curve, this is the construction height. The construction height, where you can give the heights of the sub base course, the base course, the weighting port. If you want all of these detailed cross sections in Satsurv, yeah, you can use it. But yeah, we can call it, okay, let's put it as an optional. We just want to survey it, we don't want to deal. But in some point, the customer wants these kind of things, so we have the construction height as an option there as well. Okay, so we have a video for you to design a simple cross section. Easy. With the cross sections, as you can see, there are left and right identities. So that means if I'm designing something on left, it will automatically be on right. So I'm designing my roadway with a gradient of 1.5. The road width is 4.5. That's it. So you can see there is the identities are there. They are both identical at the same part. After then I can design the sidewalk. It depends. Say for example, the gradient will be -1. The width will be 2 meter. The curve will be 0.3 or 0.2, whatever you like, whatever you want. View, there you can see the curves are being designed on both sides of the road, left and right. Now I'm going to design something on the left side only. That is the green part. Or if I can design the right side as well, I can just select on the right hand side and that's it. There you go. It's quite easy and quite simple. We would like to you to go for the Satsurv and design these cross section. It'll just take you only 5 to 10 minutes to get to know what exactly is happening there. So yeah, right now I'm designing something on the left side only. That's it. As you can see, I've designed the water side on the left part of the road, and with the details you can see all of these things. Yeah, I'm clicking apply. My road transaction is done, so we can call it a row section. Once it's done, I'm done with the cross section. Now comes the super elevation. Well, the super elevation is a science by itself. So we have, if you are from the civil engineering background, you might have known that you have to properly design the super elevation. And there are various factors, that is lateral friction factor, there are velocity of the vehicle, there are acceleration due to gravity, there are a lot of sort of other things. But right now I'm not going there. We are being very simple in this software. That means you have to design the super elevation first, and after just give the parameters there. So how we can do that? So yeah, super elevation is just as I can, in the layman language I can tell you, it's just a banking of the roads where one side goes up and the other one remains the same, just to counteract the effects of centripetal force, or which we can balance. As you can see, to balance the centripetal force, which will reduce the tendency of vehicle to overturn or skid. So let's see what super elevation. This is beautiful right now here. Okay, so this is S1, my section 1, where my gradient is normal over here, and after then, as you can see, the gradient changed where this part is going a bit up, and S2 is at its best, that is it's going more up over here, the left to the right side of the road, and then S3, then S4 comes back to normal. So let's see how we can do the super elevation over here, how to input the parameters. First is we had to give the milestone. Milestone is very important. Say for example, my milestone S1, the normal cross section is 1.5. Okay, over here, this is my normal gradient. All right. And after the in S2, my gradient will go up. That's 20 over here. All right, simple, nice, and easy. And after then, it will be the same in S3. That is my gradient will be 20, and in S4, it will be normal to life. So we have a quick video to show you how we can design the super elevation, and you can design the super elevation in the cross section part only, where we have the standard cross section here, we have the super elevation, and then we have whiteness. So let's then first is done, let's go for the second one, that is super elevation. There you go. This is my cross section over here, the super elevation, add right side of the road. So this is minus 1.5. First one is okay. Right side of the road, and I had to go 30. That is 20. I'm going for the gradient 20. Same 20, and after then back to normal. And I had to do exactly the same thing, but here I have to do the gradient as minus 20, and then after the, because in first right hand side it's positive 20 and then it's minus 20 over there. So first one is okay. Let's go to the station. Let's search the station over here. That's quite an easy. That's the beauty of this software, that you can check the cross sections here in the bottom. There you can go. There you can see there's the Superelevation there. 40, check. Same at 50, check. It's back to normal. Nice and easy. Super. So we are done with the Superelevation here. Now comes curve widening. Okay, so in curve widening, in some part, and we have roads and we want a certain curve widening, what we can do it, it's because of maybe of the, maybe you can construct for the stopping of the vehicle, or maybe there is some bus stand over there. In that cases, we are doing this curve widening. And how we can do it, as you can see the curve widening part in Satsurv. Let's see how we can put the parameters of curve widening. So first is obviously we have to give the milestone from where we have to start the curve, and we can do exactly the same thing over here, like this. Trying is slowly this. Okay, I can do same thing on the right and the left hand side as well. So let's see on W1, that is from this part, from center part to extreme edge, that is 4.5. That's a normal carriageway distance. And after then comes W2, that is 20 over here. Then comes W3, that is at station 40. That is station 30, that is 40. 20 again, and W4 will be normal to 4.5. And let's see how we can design the widening in Satsurv. We're done with the standard cross section. We're done with the Superelevation. Now let's start with the widening here. Add right side. I can do the left side. I can do the right side. Right now I'm just going for the right side only. 20 at station 20. I'm going for 4.5. Then obviously I had to add another point, that is 30. For the width is 20, and after 40. I hope you all understanding what all of these are happening right now. It's simple, it's easy. And after on station 50, I have to go back to normal, that is 4.5. Equal view, and view the station over here. We have started from 20 and we went up to 30, 40. So let's start with 30. There you can see, there you go. The curve is widening. The carriageway is widening. And after 50, it comes back to normal. We will save it, press OK, go back. We'll show you how we can do all of these things here. There you go, there's the curve widening over here. Okay? And I can do exactly, I did it on the right side, I can do it from the left side as well. So far we are done with the horizontal alignment with the 3 different methods. We are done with the vertical alignment. We are done with the Superelevation. We are done with the cross sections. We are done with the curve widening. Now comes the last part of this particular geometry is side slope, which is quite important. Side slope. What are these side slopes? Well, side slopes are generally used in the hill roads. All right. So this is my travel way or the carriage way over here. Then comes my shoulder. This is my hinge point, and after hinge point, this is my side slope. This is my shoulder, then comes my side slope, and we're going to design and we're going to learn how to design these side slopes. There are 2 different things, 2 different side slopes. One is the cut slope and one is the fill slope. So we're going to learn how we can design both of these 2 in Satsurv, and how we're going to place these 2 in a particular milestone of the particular cross section. So fill slope. So here is the fill slope where my original ground level is this. but I need to fill it. So this is my filling part. I need to fill this part. I need to fill up. Fill. All right. And then comes my cut slope. The cut slope, I have to cut this part. Cut. So let's see. Let's find out how to combine side slope with the cross section in Satsurv and how to design both of them. So first of all, these are the parameters. This is my hinge point over here. And after then my heel slope height, that is 7/2. Right now here we are going for not for the gradients, we are going for the ratio 7/2. That is, I'm going 7 in forward direction and 7 in down, or 1 or 7 in 1. And after then we are going for the create factor over here. And once the create factor is done, we can call it the stage, this part. Why the stage? Because the rainwater will come up here, be here for some time, and after then go back to my drain. And then we can design the ditch. The ditch is what we can call as the drain. So this is my drain part over here. These are the elements and the demo that we have created so far over here. And then comes my cut slope. Cut slope is easy, simple. It's just the reverse of the fill slope. So first, what we are designing is we are designing the ditch first. That we are designing the drain, and we are designing the stage, and after then we are designing the cut slope. That's it. These are offsets of hinge points over here. Once we are done with it, we have the video over here for the side slopes. Add section. The side sections, I can add the demo 1. That is, I can call it as a cut. So I'm giving the fill slopes over here. Platform. So what I'm doing is I'm first designing my fill part, and after then I'm designing my cut part. So then after then we'll both join these two things in your cross section. So ditch top width. There you go. Okay. First one is fill. Now I can add the cut one. The cut one is the same as demo 2. And I'm going for the cut part. I'm giving the name, simple and easy. In the cut, as I told you, I had to go for the ditch. Then I have to go for the platform. And now after then I had to go for the slope. So this is it. And the beauty of the software is that it will show you all these things one by one. If you have selected the ditch, it will show you, it will preview the ditch, and after the platform, and after the cut slope. And moreover, we are improving, our engineers in the SatLab, we are improving, day by day, and we are making sure that the user will get a good experience of designing the roads and good experience to handling the software in the nutshell. So this is it. We have designed the two side slopes. One is the cut side slope, and the one is the fill side slope. Let's apply it. Okay. There you go. I'll go back here. I'm going to the road stakeouts. There you go. Selecting my file. This is my view over here. I can go for the cross-sectional view. Just clicking this button. That's it. My cross-sectional view is here. I can select demo 1. Okay, it'll ask me where you want to select it, right or the left side. Okay, we'll go for the right one. That's it. As you can see, that what we have designed is there on my cross section, and you can stake out the cut and fill. How we that's like how we stake the particular cross section on the field. There you go. These are the different types of. And if I am choosing the right one, there you go. You can choose right or the left side, and you can choose you want to cut or the fill. It depends on what cross section you are in, and simultaneously, in a, say for example RD7 or the station 100, you want a cut slope, you can use it. You can use the cut fill or cut from the right or a fill from the left. Just how it is, simple and easy. Okay, so we are done with the fill side slope as well, and let's have a quick poll. So in the quick poll, we have so this is how frequently, and this is something quite important because we need to know how frequently do you use the road design option in the field controller. Are you using it oftentimes, or are you using it less frequent, or are you using it quite often? Because that makes us and our engineers to do a lot of other things in our software, to incorporate other things as well. This is something important for us to know your opinions. How frequently do you use the road design option in the field controller? Oftentimes, less frequently, quite often. Okay, thanks for your feedback. Let's get started with the construction design. So, and construction design is kind of optional. Some people use the construction design, and some people are like, okay, we have other things in the design part as well. But yeah, here we have option for the construction design, which is we have 4 construction designs here. We have the cover culvert, or we can call here it as a box culvert in some countries. This part, this is my box culvert over here, and there's a circular culvert, or we can call it a pipe culvert. Then it's a passageway, then it's a footbridge. So let's see how we can design all of these 3 things, in Satsurv. So we have an option over here. I need to love it. So there are 4 types of constructions will be abstracted to this model. So one is we have two main model. One is the straight one, and another one is the slanting one. What exactly the slanting one is? Say for example, this is my road over here, and this is my pipe culvert. So like let me understand like this. This is my pipe culvert going over here. So it's on a certain angle here. This part. And so we have to select on our construction menu here that if it's a slanting or is it a straight one. So there it is how to input the construction parameters in Satsurv. We have to give the station, at what station this construction option will come up. At what station you have the pipe culvert, at what station you have the box culvert, you have to give the station as well. Then we have to select the type, what exactly is there on that particular station. And after once it's done, we had to check whether it's a slanting one or it's exactly perpendicular to your road. So if it's a slanting one, you have to give the angle over here as well. After then, you have to give these parameters, which is front width, back width, left angle, right, no, left length, right length, center height, slope, etc. We have, I guess, a quick video just with that. Go to the construction design at station at 100 station. I'm saying that okay, I'm having a circular culvert with a slanting one, or I can go for the straight one. I'm having a slanting one at the 100 station, that means at road distance at RD. As you can see, at RD 100 I have a circular culvert, and I'm giving all the parameters over here. giving the front width, giving the length, the rise, the height if you have any, or say for example if there are some kind of a slope, you have to give the slope as well, because water has to go from one side to another side. So yeah, slope is must. There you go. Ah, done. In view. There you go. This is my details of all the, because we have the all these things that we have already carried out, that is 10 meters, 9 meters, we have all these parameters there, and with the slope as well, we have here, as you can see, the 60-degree slope. After 10, it's done. Okay, so it's done. Let's have a quick poll, and this poll is because we need to know if you are using this construction tool, this construction design. Do you find this construction design a useful option? Yes or no? Because if it's useful for you, then we can add more construction designs in it, and we can make our software better and better each day. Do you find the construction design a useful option? Do you want it in your field controller, or you're okay with it if you don't have it? Okay, thanks for your feedback. And this is really important for us. Okay, so let's get started with the next part, and which is our last part and quite interesting one, which is how to stake out roads in Satsurv. So staking out the roads in Satsurv. See, we have learned so far that we can design the roads in Satsurv, but Satsurv and in every other software, if you can use any other software in the market right now with a field controller, they have their own limitations, right? So in this particular part, what we can do is we can import a land XML file, which is an AutoCAD 3D cell file, which contains all the elements like horizontal alignment, vertical profile, each and everything, the super elevation, because we can design each and everything there, and after then just export our XML file directly to our controller, which is easy. I mean, it will ease the stakeout work for us, if we have all these details by our side and we have everything on our controller. So we're gonna learn how to import the land XML file in our Satsurv software. So we go to the road design, we import, we select the road file, that is road XML. Easy, simple. You click OK, the file will be imported successfully, and you can check all the attributes in the XML file. As you can see, there are the road alignment is tick, the profile is tick, there are different cross section is tick. So there are all the things that you can see. These are the things that are already in my land XML file. So load the file of our stakeout. It's exactly simple and easy. Let's go to the stake road, then go to the this is my file already that I have already imported. This is it. Choose a road file in the library, then click OK and enter in the main interface. Then we can start the values, and we can start the milestones and steps that I'm going to talk about this particular part in a while. How we can do that. Okay, so this is my stake out, how to stake out the center line. So while staking out the center line, I'll just make a quick line over here. Say for example, this is my center line and this is my point 0, and my client wants that I want to give point after 5 meters and after 10 meters. So say for example, if my customer said that okay, I need the points to be staked out after 5 meter interval, so I can select here as 5, and in every 5 meter I'm going for like 5. This is 5, 10, 15, 20, 25, so on and so on. This is what exactly this milestone is. Okay, I just need to quickly sorry for the mess. Okay, so this is it. As you can see over here, this milestone is 5. After then, milestone will be 10, so my point will be here. After then will be 15, my point will be here, so on and so on. Milestone 20, that's it. So yeah, so first what we are doing here is we are just staking a simple line, and after then, say for example, I had to stake the offset as well. So I have an option over here. I'll show you how. So milestone is 0, offset is 1, and step is 1. As you can see, step is 2, then the step will be 3 over here, the step will be 4, then will be here, so on and so on. I can put it as a 5, so the steps, the offsets will be 5, 10, 15, 20, 25, so on and so on. And we have a small video here. And I'm glad that you are having so much patience now, till now. Really happy that you're with me so far. Thanks. Thanks a lot. Anyways, so let's go for the stake roads. We are clicking on the road file here. This is my top view. That is my top view of my road. I can change it over here. Cross-sectional view from the top view. There you go. I change it. As you can see, this is my cross-section over here, and 1, 2, and this point here, there is my GNSS standing on my, this is, see, this particular line over here which you can see is design cross section, but right now I am like standing like here. This is my original ground level. You need to understand this is my original ground level, and this is my design section. So what it's saying you need to cut here, you need to go down 4.2 meters. Okay, this is how this red dot over here indicates where our GNSS is. Okay. Milestone. That's it. In the milestone C, as you can see, I have this point here. So if I'm giving the milestone as 5, the next point will be 5, and the one will be 10, the next will be 15, 20, 25, 30, 35, so on and so on and so on. This is it. On the part. And simultaneously we can add the offsets as well. Say for example, we have to give the left offset or the right offset, as you will be seeing in this video. Yeah. This is the milestone, and now I'm giving the offsets. The milestone is 7, so it will be 7, 14, 21. There you can see. Yeah. This is my point. This is my offset point. So my GNSS is going there, and once it's done, and after then it will ask for the next step. So it will be say for example, if the offset is 1 meter, so the next point will be at 2 meters, then 3 meters, and 4 meters. So as you can see, so this is my GNSS over here, and this is my offset. So my offset over here. Nice and easy, simple. We're not doing anything which is, which takes a lot of time. It's simple. I'm giving just the offsets, and the software will tell me exactly this is done, this point is done, go to the next point, the next point, the next point, so on and so on. This is my current line. There is another offset, as you can see. It has shifted there. And you can see here. Second. This point, and after then, if I take another point, it will be here, it will be here, it will be here, and so on and so on. So this is it. Yeah. So thank you all for holding up tight for 1 hour. I know it's a bit difficult, but anyways, I hope you got to learn a lot of things from for Satsurv and the road design specific to this road design. And we have a Q&A session as well. If you guys have any questions related to this webinar, you can ask me straight away. And there is a question bar as well. If you have any questions, just raise your hand, and we have a limited time for the Q&As here. Okay, we have a one question in our question bar. Okay, if we have a civil 3D XML file which contains alignment, profile, and cross sections, can Satsurv load all these elements? Yes, of course, it can load all of these elements itself. That's how we have shown you before as well, that you can load all of these elements of the XML file directly to Satsurv. Could you explain something about volume calculations by Satsurv? Yes, you can do the volume calculation as well in Satsurv, whether we have an option called DTM, so you can use the volume calculations for this. Any other questions?
Yes, sir. Can you hear me okay?
Yeah, I can hear you. Please go ahead.
Yeah, thank you. Yeah, so it's Isabella Pisica from Bulgaria. And thank you so much, first of all, for the presentation. It was excellent, really easy to follow. So my question would be, what is more convenient, to import an XML file from Civil 3D or to design the road in the software?
All right, so to be very frank with you, that I can suggest you that if you have the Civil 3D file, it will be more convenient for you to design or to stake out that particular file there. Or in some cases where you have a short distance road alignment, you can design the road alignment in your software, and that's it. So it depends on what exactly you're working on. If you're working on the big projects, you can go ahead for a proper land XML file where your designer will give you all these details of the road. And if you have small or short distance roads, you can do it by our software as well. That's no issue. Hope I make the question clear and answer you. Is there any other questions?
No, thank you so much again.
Thank you. Thanks a lot. Okay, we have another question from Mr. Server. Can import the DXF file as well? Yes, our new version of Satsurv software can import. We can import the DXF file in our Satsurv software as well. Yes. Any other question? Because we are just done with the time now. And I thank you all for being patient and listening to this webinar and paying attention. I hope to see you soon.